Hey guys, so today I thought I'd take some time to tell you about inductors and how they work. No math or applications in this video, just sort of short theory on how inductors function. So yeah, this is an inductor. A inductor really just means a coil of wire, and you can see it's represented by its symbol as such, which is just a coil of wire. That's all the symbol for an inductor is. And it represents it accurately. So here we have a toroidal inductor, which basically means they've just taken a toroid, or a circular piece of material that is magnetic, such as iron or ferrite, and they just wrap wire around it. And now you can get straight inductors, or so straight and toroidal are really the most common. And basically what an inductor serves to do in practical circuits is, you'll notice that you can find some really good examples in power supplies, like the switch mode power supply, or perhaps audio filters. And because what inductors basically do is, inductors are a type of energy storage device. So inductors store energy just as a capacitor does. Okay? Not the same way, but they still store energy. And it's this storage of energy that makes them resist changes. And so the thing with inductors is they behave opposite of capacitors with some respects. So an RC filter, an LC filter will react the opposite way. We'll talk about that in a minute. But anyway, essentially inductors store energy, and this energy storage makes them good for smoothing and audio applications because they resist changes in current. Okay, so how do they do this? Well, you can see, say you're to pass current through this inductor here, right? So just forget about this for a second and just look at this one. You generate a magnetic field. This blue magnetic field is generated by the coil of wire. So when you pass current through a wire, it generates a magnetic field 90 degrees to the wire, and that blue is the magnetic field. So say for our example now that you put current in this magnetic field is there, okay? The magnetic field is going to be constant. So you're going to have a constant magnetic field for your constant current. Now, you shut the current off, right? What happens is the current stops, but the magnetic field is still there. And the magnetic field will collapse down into the wire. So there's no current to sustain this magnetic field anymore, so it's actually going to collapse. And that energy that was in the magnetic field when it had been turned off, so in fact, in an inductor, the energy is stored in the magnetic field and not as a charge between two plates or foils as it's done in a capacitor. And so the energy that was in this magnetic field collapses down into the wire and becomes a current and a voltage, a charge. And so this is why you always see diodes reverse bias across inductors, is because what happens is the inductor is there to smooth something out. Because what happened, well, first let me finish explaining this. The inductor is there to smooth something out, and so when the magnetic field collapses on your motor or something, the amount of energy stored in that magnetic field is enough that it can create a very, very high voltage. Now, it's not going to be able to deliver this as a super high current, but it's going to create an extremely high voltage, which will fry anything in your circuit. And so the way they can use an inductor to stabilize a power supply is not only if you shut off the magnetic field or the current, but if you change the current. Now, this magnetic field wants to stay constant. It really likes just being a constant magnetic field. That's what the magnetic field likes the most. And so if you try to change the amount of magnetic field by changing the amount of current, it's going to resist that change. So it's going to do the same thing, add extra energy into the magnetic field or take it out of the field to make it the same. And so it's going to act just like a capacitor, and then it's going to resist changes in current. It's going to subtract or add from the magnetic field to keep the current the same, so that then the magnetic field can return to its constant state. So that's what the inductor likes best. It likes to keep the magnetic field the same. Whether it be no magnetic field, it resists having a current pushed through it initially. And whether it be having a magnetic field, and when you change it, the magnetic field will collapse into the inductor and generate a very powerful charge. And in fact, this inductor collapse can be used by some people for many applications of generating high voltage spikes and stuff.